So we are going to start with the revision of classical mechanics, people. Yes. So classical mechanics, people. And in classical mechanics, what the topics that I'm planning to cover today is first velocity and acceleration in 2D, 3D. After that, we will take Newton's laws of motion. Okay. Then we will take friction. We'll also take pseudo force. We'll take variable mass problems. These are my minimum target, and if time permits, then we will take some problems on work, power, energy too. So this is what I plan to do today. Okay, chalo, let's get started, people. So first, let's recall velocity and acceleration in 2D and 3D. It will be a quick class, and like I said, it's not a doubt solving class; it's only a revision class, people. So, but yes, while I'm teaching you something, if you have some question related to that, you can ask me immediately. Okay. And otherwise, if you have any other doubts in the topics that you have been learning, you can always mail me. So that's a thing you have. Okay. So to start with, our coordinate systems, we obviously divide them, if you remember, in 2D and then in 3D. In 2D, we have got one is Cartesian, about which we are least worried because that's our favorite. Okay, XY. Another is polar. This is where the things get a bit more interesting, r and theta. In 3D, we have got again actually two coordinate systems. One is again Cartesian, other is again polar. Okay. In Cartesian, we have got x, y, z. In polar, we have got two more. One is spherical, another is cylindrical. So yes, in spherical coordinates, we have got r, theta, phi, and in cylindrical, rho, phi, z. So we are just gearing up, people. Obviously, itna fundamental mein we are not going to go throughout the class. Okay, we're just gearing up right now. Okay, so to start with, let's directly jump on polar coordinates. Cartesian is completely time passed. Okay, so for polar coordinates, people, if you remember, the position vector, like we are talking about 2D polar. Okay, we are talking about 2D polar. Okay. So the position vector r vector, it was just r vector. No, r vector was r vector, nothing else, because r vector was position itself. However, for example, in cylindrical, in cylindrical, rho is not r vector. No, rho was actually the perpendicular distance of the point from the z-axis. Like if this is the z-axis, if this is the disk, then the perpendicular distance, that was actually rho. And if here you have the origin, then this becomes r. Okay, so r and rho are different things in cylindrical. However, in spherical coordinates, in polar coordinates, r is r. R itself is position vector. Okay, then we can write r vector as r into r cap if you want. Then we derived velocity vector. Okay, velocity vector has two components. One is the radial component, other is the angular component, vr vector and v theta vector, which we can write it as vr into r cap plus v theta into theta cap. What was our radial velocity, people? R dot. Okay. What was our angular velocity? Tangential component, angular component. It has multiple names. Tangential component. Okay. Angular component. It is also popularly known as transverse component. Okay. So you can write any of these. And that was r into theta dot, if you remember. Okay. Theta cap. Dot means first derivative, people. So when you say r dot, that was dr by dt. And when you say theta dot, that is d theta by dt. Okay. When you say d theta by dt, this is rate of change of angular displacement with respect to time. That was our angular velocity, omega. Okay. So that was vr and v theta. And then we also learned a vector, if you remember. A vector was ar into r cap plus a theta into theta cap. AR was actually r theta double dot plus 2 r dot theta dot. I'm not 100% sure if I'm writing it correctly. No, that's wrong. So AR was r double dot minus r theta dot square. And a theta was r theta double dot, yes, plus 2 r dot theta dot into theta cap. Okay. And in this, when you say theta double dot, people, pardon?
R cap.
R cap.
Absolutely, absolutely. That's absolutely R cap. No wonder. Okay. So when you say theta double dot, that's actually second derivative of angular displacement with respect to time So that's angular acceleration, because I can write this as d by dt of d theta by dt. And what is d theta by dt? D theta by dt is actually omega, people. D theta by dt is omega. And d omega by dt, this actually becomes alpha at the end. So we're just recalling a few things. If you want, you can quickly write things or take a snap or whatever. But because I just want to take numericals and we're just gearing up, like I have said. Otherwise, we are not going to do this fundamental. If radial and transverse velocities in plane polar coordinate system are always proportional to each other, then what is the equation of path? K and A are constants, random constants. You can write C1, C2, you can write alpha 1, alpha 2, doesn't matter. These are random constants which you are allowed to create your way. Okay. So they have given us radial and transverse are proportional to each other. VR velocity, radial velocity is proportional to transverse velocity. Okay. Radial velocity is r dot. If you remove proportionality, you will have a constant. If you remove proportionality, there will be a constant. Let's say constant k. You can write C1 also, doesn't matter, right? Whatever constant you want. Constant k into v theta. What is v theta? V theta is r theta dot people. What is dr? What is r dot? Dr by dt. K into r. Theta dot means d theta by dt. Achha, by the way, just a second. When you say equation of path, what is the meaning of that? Equation in Cartesian is relationship between y and x. For example, y square equals to 4ax, which is parabola. X square plus y square equals to r square, which is circle. So when you say equation, it means relationship between the coordinates. Relationship between y coordinate, x coordinate. Relationship is in the polar world, no? Plane polar coordinate. So you have to find relationship between r and the theta. Correct? So dt gets cancelled. I think you know how to find this relationship. We are just supposed to integrate, right? It's variable separable, people. Dr upon r, this is k d theta. Integrate both the sides. Integration of dr upon r, this is k integration of d theta. Okay? Give any initial values, whatever values you want to give. They have not exactly given us any constant, but okay. What is integration of dr upon r? That's log r. Okay. Wait, I think we should give some initial values now. I'm also thinking now. But we cannot give 0. They should have given us some initial value actually here. Kya kare? Okay, let's just write it this way, maybe, you know. Integration of dr upon r, that's log r. This is k. Integration of d theta, that's theta. Let's say there is some another constant c. Because limits are not given to us, right? Have they given us initial values, final values? No. So when they don't give us initial and finals, we are supposed to write it in the form of c. Now the problem is we don't have log here. Okay, it means we are supposed to take exponent on that side. You know? It has exponent e, people. So I can write this as e raised to k theta plus c. है ना यार? People, what is log of a to the base b equals to c? A is b raised to c. है ना? So log of r to the base e, k theta plus c, r will be e raised to k theta plus c. Remember, you are allowed to ask me doubts related to what we are learning. And I am running fast because it's a revision class, but you can always tell me that, sir, please re-explain. No problem. Okay? So r e raised to k theta plus c. Okay, so we are very close. I can split them, e raised to k theta, e raised to c. So this becomes e raised to k theta. People, e is a constant, 2.71 or something. C is a constant. What is constant raised to constant? Another constant. Let's say C2. Right? Whatever notation you want, right? C2. So your answer r is C2 e raised to k theta. Do we have something like that? We have got r, but we need exponential. We have r is a e raised to k theta. So instead of C2, they have used a. K is k. Note, these are constants. You can write constants however you want. So answer is definitely option C. I hope you understood this. Tell me if not. Make a note. A particle moves in a plane with velocity this such that Vr is 3 by 4 v theta. The time dependence of the magnitude of the velocity is this. It is given then this. At what time this? Okay, blah, blah, blah. So let's take one thing at a time. First, we have a relationship between Vr and v theta. Using this, just like last time, we can derive a relationship between r and theta. Just like last time. Let's do that first of all. So Vr is 3 by 4 v theta. Okay. Vr is dr by dt. This is 3 by 4 v theta, which is d theta by dt. Dt gets cancelled. We have got dr. Achha, v theta is r d. You can always argue. V theta is r into theta dot. No. So r into dr by dt, d theta by dt. You can always argue. Please tell me if you have any confusion. Okay, it's r theta dot. So r into d theta by dt. D gets cancelled. We have got dr upon r. This is 3 by 4 d theta. Let's integrate. So integration of dr upon r. This is 3 by 4 integration of d theta. Have they given us limits this time at least? Yes, they have given us. At it is given that r is 1 when theta is 0. So when theta is 0, the value of r is 1. Let's say when the value of theta is theta, the value of r is r. Okay. So that way we will get a relationship between r and theta. Now you don't have to write constant c now. Now we will not write constant c because we have got limits. Okay. So integration of dr upon r, that's again log r. This is equals to 3 by 4 integration of d theta, which is theta. What is lower limit here? 1. What is upper limit here? R. What is lower limit here? 0. What is upper limit here? Theta. Upper minus lower. So that's log r minus log 1. This is 3 by 4 theta minus 0 log r minus what is log 1? That's 0. You know, 3 by 4 theta. So we have got log r is 3 by 4 theta, people. Or you can say r is e raised to 3 by 4 theta. R is e raised to 3 by 4 theta. We have got a relationship between r and theta right now. Copy this much, fatafat. Then we will see what to do. Okay. So again, what I have done is I've taken exponent on that side, so r becomes e raised to 3 by 4 theta. Now let's read and cancel the things which are already used. A particle moves in a plane with velocity. This we already know, yaar. It's time pass. The whole first line is time pass. We already know this. Vr is 3 by 4 v theta. Okay. We have already used this, but we will write it. Vr is 3 by 4 v theta. So this is the information that they had given us. Okay. The time dependence of the magnitude of the velocity. People, have they mentioned which velocity? Radial? Nahi na. Have they mentioned transverse? Nahi na. It means which velocity is this? Total velocity. When they don't mention magnitude of which velocity, it means they have given you magnitude of the total velocity, which is 5t. Okay, so let's now play with this, people. Magnitude of v is 5t. What is magnitude of v? Under root of vr square plus v theta square. This is 5t. Okay, so this is under root of what is vr, people? 3 by 4 v theta. Okay, the whole square plus v theta square. This is 5t. We can square on both the sides. Okay, or हाँ, square करे ना करे, नहीं करेंगे तो भी चलेगा वैसे, because this is actually 9 v theta square upon 16 v theta square plus v theta square. This is 5t. So this is under root of 9 plus 16, which is 25 v theta square upon 16. Denominator does not have v theta square. Just a second. Okay. Huh. So 3 ka square, that's 9. 4 ka square, that's 16. V theta ka square, that's v theta square, people. I've just cross multiplied. 9 plus 16, that's 25. V theta square by 16. This is 5t. Under root of 25 is 5. Under root of v theta square is v theta. Under root of 16 is 4. This is 5t. So we have got relationship between 5 gets cancelled. That's interesting again. So we have got v theta is 4t. What is v theta? R theta dot. This is 4t. Okay. So r, what is theta dot? D theta by dt. This is 4t. And what is r, people? E raised to 3 by 4 theta. Outstanding. So e raised to 3 by 4 theta, that's r. D theta by dt. D theta by dt. This is 4t. And I think now we can get another equation here. We've got e raised to 3 by 4 theta d theta. This is 4t dt. Integrate both the sides. Integrate. Integration of e raised to x is e raised to x. Integration of e raised to 3 by 4 theta is e raised to 3 by 4 theta. You have to divide by the constant 3 by 4. 4 outside. Integration of t, that's t square by 2. But what about limits? Let's check the limits. Huh? So it is given that r is 1, theta is 0 at t equals to 0. So when time is 0, theta is 0. When time is 0, theta is 0. So let's say at any time t, theta is theta. What is it that they are asking us, by the way? They are asking us at what time theta will be 4 radians. Okay, so let's substitute that now. They're asking us at what time theta will be 4 radians. So let's substitute that. Where is eraser? So let's say we want to find at what time, this time, theta should be how much? Theta will be 4 radians, people. Okay. I hope the problem is understood, the question is understood, the solution
Yes,
so
sir.
far is understood.
Sir, इसमें constant नहीं आएगा integration?
No, Ari, you have put the limits, no?
अच्छा, okay, definite है, okay.
Yeah, definite integration. Okay. So we have got 4 by 3 e raised to 3 by 4 theta. 4 by 3 e raised to 3 by 4 theta. Lower limit is 0, upper limit is 4. 4 by 2 is 2 t square. Lower limit is 0, upper limit is t. Okay. So we have got 4 by 3 upper minus lower. So e raised to 3 by 4 theta. Theta which is what? 4 minus e raised to 3 by 4 into 0. Dekho, listen people for a second. Mostly it happens with many students. When you substitute 0 now, you end up thinking the value will be 0. It's a human tendency. Many a times that will happen. That suppose if you have cos theta and if you are substituting the lower limit 0, cos 0, you might just end up writing 0. Have patience. E raised to 0 is 1 here. Cos 0 is 1. Not every time when you will substitute 0, answer will be 0. Now. At places, it may not even be 0. So here it's not 0. Don't think it is 0. Here you have a value. Okay. Take care of that. So this is 2 into upper minus lower. That's t square minus 0. So this is 4 by 3 e cube minus 1. E raised to 0 is 1 now. This is 2t square. Okay. E cube they have given us, by the way. E cube is 20. They have given us. Okay. So this is 4 by 3 into 20 minus 1. Okay. This is 2t square. So we have got 4 into 19 upon 3 into 2. This is t square. So we have got t which is under root of 2 ones are 2 twos are 2 19s are 38. 38 by 3 seconds. Answer is option B. Chalo. So now let's just also pen down the formula for like you already have the formula with you, but still the value of velocity and acceleration. In first we will learn cylindrical and then we will learn spherical, people. So see, for 2D polar, the value of r vector is r into r cap. The value of v vector, which is vr into r cap plus v theta into theta cap, where vr is r dot and v theta is r theta dot, and the value of a vector is r double dot minus r theta dot square into r cap plus r theta double dot plus 2 r dot theta dot into theta cap. Okay, I had given you a shortcut trick to remember 3D cylindrical if at all you ever get confused. 3D cylindrical, it has rho, phi and z. Here you have got r and theta. The role of r is played by rho actually. The role of theta is played by phi, and z is just a vertical height, people, a vertical height. Basically, when z becomes 0, so the whole graph, the whole cylinder becomes a circle. It's a cylindrical coordinates now. So if cylinder does not have z-axis, people, if cylinder's height becomes 0, what will happen? It will become a 2D circle. It's like you have compressed the cylinder. So cylindrical coordinate converts itself into 2D polar when z becomes 0 basically. So all the formulae that you have here should also be obeyed here too. So for an example, if we talk about r vector, here you have r into r cap. The role of r is played by rho. So we have rho into rho cap. Just that because you have an additional z, we have an additional term z into z cap. That's it. Next, what is velocity vector? Here you have r dot into r cap. Here you have rho dot into rho cap. Here you have r theta dot into theta cap. Here you have rho phi dot into phi cap. The role of r is played by rho. The role of theta is played by phi. And just that because you have z here, what is derivative of z? Z dot. That's it. An additional term. Then you have acceleration vector, which is again r double dot minus r theta dot square. So rho double dot minus rho phi dot square into rho cap. Correct? Then rho theta double dot plus 2 rho dot, convert r theta into rho phi again. So this becomes rho phi double dot plus 2 rho dot phi dot, okay, into phi cap. And just that you have got z dot. What is derivative of z dot, people? It's z double dot z cap. This is how you remember cylindrical. I personally till date have not exactly by hearted cylindrical. I take a minute, I recall 2D polar, and I just write cylindrical with a good analogy. Okay? But yes, in spherical, we don't have as such great tricks. And I don't think they will probably ask you a direct question on spherical. It will be very harsh of them to ask a direct question on spherical because the formula becomes too complicated there. But still, we will pen down the formula because I want to take a question on that. So even I have not by hearted these formula, obviously. Just a second. If I don't want to do a mistake in writing the formula, so let's pen down these. Okay, so what happens in spherical? In spherical coordinates, we have got r, theta, and phi. Okay, so r vector, that's still r into r kappa. That thing doesn't change. That doesn't change. But yes, v vector, it has got components. So to start with, the first component is fine, r dot into r cap. That is still the same. The second component is also fine, r theta dot into theta cap. That's still the same. It's only the third component that now creates first. We have got a third component here, which is r sine theta into phi dot into phi cap. This is an additional third component. But the thing is, after differentiating this, acceleration becomes very complicated. Velocity is still fine. Velocity is still easy to remember now. R dot into r cap, that's 2D polar. Yeah. R theta dot into theta cap, that's also 2D polar. Just that this is an additional term. R sine theta phi dot into phi cap. I had this one. If they ask you acceleration, that will be too harsh. But okay, acceleration, which is the first few terms will be same. What was the first term, people? R double dot minus r theta dot square. That has to be same. That cannot change. Why? Tell me one thing. Again, a sphere, if you remove azimuth, or like if you say that there is no azimuthal angle at all, then you will land up in r theta component. So if phi is not present at all, if you ignore all the phi, then you are left with r theta, which is nothing but again what? 2D polar, people. So sphere can be converted to 2D polar if phi becomes 0. Similarly, cylindrical can be converted into 2D polar if z becomes 0. You know? So anyway, so the first term remains same. Now the additional term that we have here, it is minus, I will just use color maybe for a good contrast, which is given by minus r sine square theta into phi dot. Okay. And if you have by hearted these things, it's a good time to check your by hearting skills. Okay. R cap. That's the first term. The second term. Again, the first term shouldn't change, people. R theta double dot plus 2 r dot theta dot. We know this already. This should exist. But there will be an addition. The addition is minus r sine theta cos theta phi dot square. Okay. Into we have got theta cap. Okay. Okay. Next. And the third term, complete term, which will be your azimuthal component, the phi term, which is given by 2r dot sine theta phi dot plus 2r cos theta into theta dot into phi dot plus r sine theta phi. Have any of you by hearted these things? Phi cap.
Cylindrical or velocity of spherical. That's it.
How? I mean, yes,
Acceleration
it's better. Exactly. Like by heart, and what I will suggest you also now, just by heart velocity. If at all there is a question on acceleration, then also I will tell you know what they will ask max. They'll probably ask you just radial component or tangential component. So maybe you will have to probably derive things respectively. That's what I mean. Just if you by heart this now, how much time will it take for you to derive this? 2 minutes maximum if you are in good confidence. You can invest 2 minutes. If it's a question for 2 marks, you can invest 2 minutes any day. Okay. So you can always derive this just by heart velocity. Don't stress yourself to by heart acceleration. Okay. So again, I'm not sure if I've written all the terms correctly here, but okay. Chalo, let's proceed. So we have got a particle moves with phi equals to constant, theta dot equals to omega is constant, and r equals to r0 e raised to beta t. Its transverse component of acceleration is. First, you have to identify the system. Is it 2D, 3D? And if it's 2D, then which? If it's 3D, then which? So we have got phi, we have got theta, and we have got r. So we have got r theta phi. So obviously it's spherical coordinate system. And in spherical coordinate, they are asking us transverse component of acceleration. It means they are asking us a theta. Okay. Now, a theta is given by, we remember the first two terms as I think so very easily. which is r theta double dot plus 2r dot theta dot. Yes, additionally, we have got an extra term, and that term was, what is the extra term here? Minus r sine theta cos theta phi dot square, people. We have got minus r sine theta cos theta, r sine theta cos theta phi dot square. This is an additional term, but okay. The best part right now is they have mentioned that phi is constant, so phi dot becomes 0. So anyway, we are not supposed to by heart remember that anyway, luckily here. Okay, so phi becomes phi is constant, so phi dot, because phi dot is what derivative of phi, no? And derivative of a constant would be 0 p. Phi is constant, they have given us. So this term becomes 0. Next, theta dot is constant. People, if theta dot is constant, it means derivative of theta dot, theta double dot will also be 0. It means this term also becomes 0. So what are we left with? Just 2r dot theta dot. Okay. R dot we can calculate. What is r? R0 e raised to beta t. So r is given to us. R0 e raised to beta t. Let's calculate derivative of r dot. R0 is a constant. Derivative of e raised to x is e raised to x. But what is derivative of beta t? Beta. You will redifferentiate beta t, people. B into derivative of t, that will be 1. B into 1, that is beta. So we have got r0 beta e raised to beta t. Okay. So we have got 2. What is r dot, people? E raised to, sorry, r dot is r naught beta e raised to beta t. And what is theta dot? Theta dot is omega. So which is our option? Option A. Copy please. That's the answer. So it's not difficult. And listen, even if this question would have been for 1 mark or 3 marks, I understand you may not remember this formula. You remember velocity. Take 2 minutes, derive acceleration patiently. After derivation, once you have this formula, how much time did it take to get this result? Hardly 1 minute. So in 3 minutes, you are getting the result now. It's fine. Every question will require only 3 minutes, you know that, on an average. 180 minutes, 60 questions. Okay. So don't stress yourself to by heart acceleration. If at all they plan to ask a question on this, it has to be something like this on spherical. It has to be something. Okay. Next, okay, proceeding ahead. So I think these were the only questions that I wanted to take on the first chapter, but let me see what is the fourth question. Fourth is now related to Newton's law. So the first velocity 2D, 3D, this is what is expected from us. Usually they will ask you expressions or they will ask you equation of path or something like that. Mostly the questions will revolve around that. Mostly it will be related to 2D polar, nice 2D polar questions. And if at all it will be 3D question, then it cannot be something very humongous, people. And they can also create a good question on this related in MSQ section, where they're asking you the derivatives, If you remember r cap, theta cap, phi cap, those are unit vectors, but these are not constant unit vectors. So you are supposed to derive them. And just recalling a few things related to that, people, in 2D polar, do you remember r cap is replaced with what in complex number?
E to the power I theta.
E power I theta.
E raised to I theta, okay? And theta cap is replaced by?
Iota e raised to iota theta.
Yes, iota into e raised to I theta. Basically, people, if this is point P, if this is an initial line, origin, suppose, and this is an initial line, okay? Suppose somewhere here you have point P, okay? Then this is your direction of r cap. What is direction of theta cap? It's always tangential, and tangent is always perpendicular to radius. So for example, this is your theta, like from here to here, this is your theta. So this creates a circle actually. So you are supposed to draw tangent here. This is the direction of theta cap. Theta is always perpendicular to r. Okay. So actually what happens here, if you remember, is this thing. Wait. So direction of theta cap can be found. It is the same direction, e raised to I theta only, just that you have to add additional 90 degree. Because if r is like this, then theta is 90 degree ahead, people. So you have to add 90 degree. You have to add pi by 2. You have to add pi by 2 to theta. Then you get theta cap actually. Correct now? If this is x and if this is y, so y is 90 degree ahead. So if this is r, if this is theta, theta is 90 degree ahead. So you add 90 degree to it. And then what you do further, you split it, e raised to I theta, e raised to I pi by 2. And here you apply the Euler's formula. What was our Euler's formula, people? E raised to I theta is cos theta plus I sin theta. है ना? So e raised to I pi by 2, this is cos pi by 2 plus I sin pi by 2. Okay, so e raised to I pi by 2, that becomes basically cos pi by 2 is 0, sin pi by 2 is 1. You are just left with I. So e raised to I pi by 2 is just I, people. E raised to I pi by 2 is just I. So you get I e raised to I theta. So this is theta cap. And what maximum they can also ask is, what is derivative of r cap? What is derivative of theta cap? Because the derivative of these unit vectors, it's not 0, people. Their derivative exists. Derivative of I cap is 0, j cap is 0, k cap is 0, but their derivatives are not 0. Chalo, next. Okay. And also another important formula of unit vector was this, like any unit vector in the world, let's say p cap, it is given by the partial derivative of r vector with respect to the corresponding variable upon the magnitude of the numerator. And this is what you are supposed to use to find any other unit vector in spherical coordinates and let's say cylindrical coordinates. For example, if you talk about, let's say, cylindrical, okay, and suppose they are asking you that what is the expression of phi cap dot, derivative of phi cap dot. Obviously, we have not by hearted this thing, but you can calculate phi cap. Now, how can I calculate phi cap? You need to recall r vector. What is r vector in cylindrical, people? It's rho into rho cap plus z into z cap. First thing. Okay. Let me make it a bit simpler at the moment. Suppose I'm asking you, let's say, rho cap dot, maybe anything, but whatever. So the point is, suppose r vector is given to you, rho into rho cap plus z into z cap. First, you can find r cap. How can I find r cap? Derivative of, sorry, not r cap, rho cap. We can find rho cap. How can I find rho cap? It is derivative of r cap upon partial derivative with respect to what? Rho b. If you want to find phi cap, then phi. If you want to find z cap, then z. Whatever is the term you want to find, that term you have to use, and then magnitude of the numerator. So take derivative of this, substitute it here, and calculate. We did this whole derivation thing in the class. So once you have rho cap, once you have rho cap, then you differentiate it, and then you will get rho cap dot. Similarly, once you have got z cap, then you will differentiate it, and then you will get z cap dot b. Okay, but we have done this whole thing as a derivation only in the class. But the point is, this formula will be very significant because you have not by hearted those derivatives. But what if they ask you those derivatives in an MCQ? Then this is how you will find it. Go through the derivation once. Huh? Just go through it. Don't by heart it. Just go through the procedure so that if a question is asked, you know what to do after that. Chalo, next. Please give heading Newton's law. Well, there is no theory in this. In this chapter, there is probably just problem solving and problem solving. Huh? I mean, theory, whatever theory we had, we covered those fundamental stuff. Like first law of motion, second law of motion, third law of motion. The only important concept that you need to remember is related to the Newton's second law, theoretical. I'm just speaking theoretically right now. That is rate of change of momentum. The thing is, you need to remember that force is mass into acceleration. This is not always valid. This is not always valid. You know, recently there was a paper that I had conducted and a student had asked me a question. Let me just recall it. Hang on. It was something related to this only, not this exactly, but so the student had found torque using r cross F, but the answer did not match. Can you tell me what could have went wrong? Just asking if you are able to think, no problem. The student used torque as r cross F, but the answer did not match.
Mass maybe not. Mass maybe does not constant.
No, there is no significance of mass here. No. That is for this thing. What you are speaking about is for NLM. So I'm purposely creating another question on this. Okay. The thing is, people, what is the most fundamental definition of torque?
Rate of change of angular momentum.
Exactly, rate of change of angular momentum. And how do you write angular momentum?
R cross P.
R cross P.
Who told you that R is constant all the time? People, only if R will be constant, then you can throw it outside the derivative. Huh? only then you can write r cross f. R cross f is not always valid, yeah. R cross f is not always valid. This is something which we have not discussed, but I remember discussing this with the student when this paper was conducted. Okay. So make a note, R cross f is not always valid. Only when R is constant, you can throw it outside. Because if it is not constant, then what will happen, people? Then you will also have dr vector by dt cross p vector. You will also have first constant derivative of second, second constant derivative of first. You apply the UV rule here, right? So R cross F vector, and then you have an additional term. What is dr vector by dt? That's V vector cross P vector. Chalo. So very similarly, here also, people, when you write forces rate of change of momentum with respect to time, this is always valid. You cannot say forces mass into acceleration, this is always valid. We cannot say that this is always valid. Why? Because when you write this d by dt of momentum, this is actually mass into velocity. Only if mass is constant, you throw derivative outside. Otherwise, obviously, there is another option, v vector dm by dt, and this additional thing is known as thrust force. So this is the only important theory in the chapter. Otherwise, it's mostly about problem solving. We draw free body diagram and solve. And yes, in friction we have other theory, but this is only important theory. Okay. A pendulum is suspended from the roof of a train and makes an angle of 3 degrees with the vertical. Find the acceleration of the train. Actually, they shouldn't have given this additional information, but okay. So basically, this is a pendulum. Right now, this is in some box. Let's say box is a train. Okay. See, I couldn't find time to draw this with a scale, so I have just drawn it with my own hands. I have personally typed these questions for you all, okay, so that we save time in the class. I don't have to write these questions in the class, but okay. A pendulum is suspended from the roof of a train and makes an angle 3 degrees. Find the acceleration of the train. So, first of all, logically, they have not given us the direction of acceleration. You have to first guess the acceleration direction. Obviously, it has to be on the right side now. Only then there will be a jerk on the left side. It's only logical. The jerk, the pendulum will tilt on the left only if acceleration is on the right. Just like, bike goes up and you go back. So first you have to guess the acceleration direction. It has to be on the right side. That's first thing. Next. And now you know what to do. Free body diagram and time pass stuff. Okay. So we have got mg. We have got tension T. We have got acceleration. I've already told you, people, we will always choose x-axis as the direction of acceleration and perpendicular to x-axis as the y-axis. Perpendicular to acceleration as the y-axis. And all the forces must be along these two axes. So mg is already along negative y. I don't have to resolve t. But the problem is with tension T. T is neither along x nor along y, people. So we have to resolve T into components. mg you will not resolve because mg is already along y. Acha, listen, I'm speaking fast. I know that you have to tell me if you want me to go slow. Okay? I repeat. Next. So tension is already, people, at an angle, and we can divide it into components. We have to divide it into components because we want forces along x-axis and y-axis. So let's divide. We have got two components. First of all, what about the angle? Here you have 3 degrees now. So this will also be 3 degrees. Z angle, Hana? So this will be 3 degrees, people. So this will be T cos 3 and this will be T sin 3. That's it. So is mass oscillating up and down? No, mass is not oscillating. Mass is in equilibrium. It has created an angle and now it is stable, people. That's it. Okay. So total upward is total downward, I can say. So T cos 3 is equals to total downward, which is mg. Because there is no oscillation up and down, upward has to be balanced by downwards. Next, however, you are observing from outside. Remember, you are attached to Earth. You are seeing that the train is moving in the forward direction. So there is mass into acceleration on the right side. However, it is not oscillating up and down, and hence you said upwards is downwards. But you are seeing that the train is going on the right side. So mass into acceleration. Who is the force on the right side? There is only one force on the right side, and that is T sin 3. That is T sin 3. Divide them. Let's divide. So T sin 3 upon T cos 3. This is equal to MA upon MG. MA upon MG. I just divided them appropriately here. T sin upon T cos. This is MA upon MG. Just divided them appropriately. So TT gets cancelled. Sin upon cos. That is tan 3 this is A by G, and A is G tan 3. A is G tan 3. People, when theta is very small, when theta is very small. But remember, there is a mistake which students may do in this. Huh? Cos theta? What cos theta?
tan theta लो theta होगा sir.
tan theta cos theta
वन
वो
होगा
1
ना,
हाँ हाँ
1 हो
हाँ
जाएगा.
साइन थीटा में थीटा, cos थीटा में वन.
हाँ. That's what I'm saying. But okay, well, let me add that. So obviously you know that sine theta is written as theta. Obviously you know that tan theta is written as theta. Yes, and cos theta is written as 1. I was saying a common mistake a student will temptingly do is, if I will give you theta is 1 radian. People, 1 radian is not small angle. 1 radian is a large angle. 1 degree is a small angle. Pi radian मतलब कितना होता है? 180 degree.
180 degree.
Pi radian मतलब कितना people? 3.14 radian. If 3.14 is 180 degrees, then 1 radian would be around 60 degrees, people. 1 radian, okay? 1 radian is not a small angle. Write it in note. 1 degree is small, 2 degree is small, 5 degree is small, 10 degree is small. 1 radian is how much? 1 radian is 180 upon pi degrees, people, which is around 60 degrees. 1 radian is not a small angle. A common mistake which again students can do, okay? But anyway, so they have given us degrees, so that's a good thing. So G tan 3, I can write this G into 3 degrees, but don't write 3G, because this again can happen. You might just end up writing 3G as the answer. People, answers must be in radians. So degrees are not the assignment. 3G is not the answer here. So this is G into 3 into degree. Convert this into radians now, which is pi by 180. Okay, so 3 ones are 360s are, and then you have got you can write GS 10 maybe. So 10 pi by 60. So this is around pi by 6, approximately 0.5. Nearest answer to 0.5, D. That should be the answer. I hope you have copied things now. You can tell me if you're writing. So here's one. A block A is able to slide on a frictionless incline of an angle theta and length L, kept inside an elevator which is going up with uniform velocity V. Find the time taken by the block to slide down the length of incline if released from rest. Okay, so they have given us a block is able to slide on the frictionless surface and the length is L. This length of this surface is given to us, and that is L. Okay, good. Find the time taken by the block to slide down the length. Actually, a word should be written complete length, because diagram is not accurate. So slide down the complete length. So initially the block must be at the edge, people. So in order to slide down the complete length, they're asking us the time taken. So we know the formula, S is ut plus half at square. Correct? What is the distance traveled? L. L is the distance traveled. Initial velocity, that was 0. Okay. We want to find time, right? So plus half at square. So we have got L is half at square. We have got 2L upon A. This is T square. So we have got T, which is under root of 2L by A. Now the question is, we want to find acceleration. Remember, acceleration is not gravity, because you are not falling vertically, you are sliding down. So component of gravity is acting. Gravity is not acting. So we have to resolve things. So listen, let's do one thing. We can throw our, if you remember, our crow inside, or maybe whatever, our Sharad Kandi guy inside the lift. Okay, we'll take pseudo force as the problem here. Since system is going upwards, people, since system is going upwards, there has to be a pseudo force downwards. But the thing is, they have mentioned it is moving with uniform velocity, people. Have they mentioned acceleration? No,
No, sir.
When they say velocity is uniform, it means acceleration is 0.
0.
Okay, acceleration is 0. So there is no any additional acceleration right now. However, for your understanding, you can write that there will be a pseudo force, which is mass into acceleration in the downward direction. A pseudo always acts in the opposite direction, people. But pseudo force is 0 at the moment. Okay? So what do we have? We have got this block. it has got mg in the downward direction. It has got a pseudo force which is also zero actually, which is also zero. Okay, and normal reaction is like this. Normal reaction is like this. Acceleration is happening in this direction. So we want forces in this direction. So let's find the forces along this direction. Let's resolve them now. Fp is not supposed to be resolved. Fp is anyway zero. Okay, so we just have mg people. So mg can be resolved in two components, one component and second component. Now take care of the angle. Huh? Listen, I repeat, never by heart some of the popular formulas. For example, you have by hearted this thing. You have seen this in most of the problems, like A is g tan theta. So it's a very popular formula. Na? A is g tan theta happens in most of the problems. But the thing is, it can also become g cot theta if I shift the theta people to the apex side. For an example, here I have given you theta. I can give you the same problem where I have written theta here. Then, for example, if we do this question in the class, if in the mock test that you will be giving, same question is asked, do not be in a rush to mark the answer. Just see whether the angle is also correctly drawn or not. What if I draw the angle here? Then tan will become cot, sine will become cos. Take care of the few things. Huh? So anyway, so this is theta. Here, something like this. Somewhere here I have got theta. So people, this will be also theta. We know this, no? Okay. So this becomes mg cos theta. Okay. And this becomes mg sine theta. So normal reaction is balanced by mg cos theta. Okay. And mass into acceleration is provided by whom? Mass into acceleration is provided by mg sine theta. So acceleration is g sine theta. Remember, it could be g cos theta if theta was interchanged. Okay. That's it. So our answer is ready. Time taken is how much? Under root of 12 upon acceleration, which is g sine theta. Answer is option. Huh? Okay, sorry. All of them are. Okay. I was so when I wrote this, copy this please. So when I typed these questions, I copied A in option B. I was supposed to make one of them as G plus A, one of them as G minus A, but I did not do any of that. Okay. Make a note. Ask me if you have any questions, please.
मैंने ऑप्शन देखे तो none of these होगा आंसर.
Okay. Yeah. Acha, by the way, if same question I would ask, and if acceleration was given to you, then what will be the possible change in the answer?
Add हो जाएगा.
जी प्लस हो जाए.
Okay, G will become G plus A. Okay. Because obviously when we go up, people, we feel heavy, na? So the net effective gravity increases. So effective gravity increases, G becomes G plus A. And another way to understand that is, there is Fp, na? Fp is ma actually. If acceleration would exist, then Fp is ma. So basically, the net force in the downward direction is m into G plus A. Okay, so m into mg plus ma. Net force in the downward direction, take m common, it's m into G plus A. So now you have to create component of this h. So here you will have m into G plus A sine theta. Okay, and here you will have m into G plus A cos theta. Okay, so m into G plus A sine theta is m. Okay, now m into G plus A sine theta is actually m. Okay, so mm gets cancelled. Acceleration becomes what? Acceleration becomes G plus A sine theta this time. Or you can simply understand that the effective gravity increases, it becomes G plus A. That's it. Okay. Okay, so let's do this, people. If the mechanical system shown below is in the static equilibrium, whenever things are in equilibrium and whenever you have three component forces, you don't have to solve the physics of it. We have learned Lamar's theorem, people. It's not an exclusive part in JAM syllabus. It's not there in JAM, but we learned it so that our life could become easy. Okay, and this problem is around. They're asking to find the value of tension T. So it's only time pass. Just look at this area. Okay, you don't have to even look at the other side. This is tension T. Here you have got M. Okay, so here you have got mg. Okay, and here whatever is the value, we don't care what is the value here. Call it T2 if you want. Okay, so they have given us this is 45 now. It means what is this total angle? 135, 90 plus 45 around 135 people. Again, what is this angle? This is 90. So what will be this angle again? This will be also 135, correct? Sum of all should be 360 now. So 135 plus 90, 135 plus 90 plus this remaining angle, that should be 360. So this remaining angle, if you calculate, you will again get 135. Okay, so this will be again 135. And now you know your favorite Laminar theorem. So how do we say? It's basically the side, I mean the force T2 upon sine of angle in front of it. What is the angle in front of it? 90. Please tell me if you want me to reaction in any part of this. I'm assuming you remember this. Okay, so T2 upon sine 90. Similarly, T, this is T upon angle in front of T. What is angle in front of T, people? 135. So T upon sine 135. Okay, this is mg. This is mg. What is angle in front of mg? Again, angle in front of mg is 135. So mg upon sine 135. That's it. This is Laminar theorem. Force upon sine of alpha plus 4 is equals to force upon sine of alpha is equals to force upon sine of alpha. Alpha is the angle basically in front of it, respectively. So that's it. They are asking you to find the relation between T and mg. Sine 135, sine 135
Yes,
gets
sir.
cancelled.
Clear.
T is mg. Time pass. So the thing is, now that we have got g by 4, there will be an additional pseudo force acting on each of the objects, and all the calculations will massively change. And this is very impressive. I think I'm not sure from which book did I take this question. Maybe I directly took this from an H.C. Verma. Maybe, as far as I remember, in one of the unsolved problems. But okay, very interesting, because I'm impressed with this option. 6 kg was there. Okay, so let's do this, people. So what do we have? Let's start with 2. Let's start with this 2 kg. I have got, or no, let's start with 4 kg first of all. So I've got 4g in the downward direction, and now there will be a pseudo force to people. Okay, what will be the pseudo force? Mass into acceleration. Okay, what is
So
mass?
9 by 4 in SI.
It's not 9 by 4, it's g by 4. Huh?
Or G by 4.
It's g by 4, is g by 4. So this is pseudo force, which is mass into acceleration, which is 4 into g by 4, people. Okay, and now there is a T2 here. There is a T2 here, and system is also accelerating. Very nice, huh? Okay, so what do we have? Mass into acceleration, which is 4 into acceleration. This is sum of all the forces. The force in the direction of acceleration, 4g plus, hang on, what is this? Achha, this is mass into gravity. Now, people tell me if you have any questions. First, this is weight, 4g. And now this is pseudo force, which is mass into acceleration, which is 4 into g by 4. Okay, so 4 gets cancelled. I'm just left with g. Okay, and in the opposite, I have got T2. So 4a is 5g minus T2 actually. This is our first equation. Please tell me if you have any questions. Don't hesitate. All good? Next, let's talk about 2 kg. Nice. Okay, so we have got 2g in the downward direction. Then we have got pseudo force, mass into acceleration. It is 2 into what is acceleration? G by 4. And then there is T2 also, because 2 will experience a tension due to this. Huh? There will be a tension also, T2 also in the downward direction. So many downward forces. This is such a good question. Okay, and we have got T1 in the upward direction, and we have got acceleration in the downward direction. Okay, good. Please tell me if you have any questions. Don't hesitate. So mass into acceleration is given by T2 plus 2g plus g by 2 minus T1. So 2a is given by T2 plus 2 2s are 4, 4 plus 1, that is 5g by 2 minus T1. Okay, that's next equation. Copy this much. Next, let's talk about this thing here. System is going acceleration in the downward direction. Here it is going in the upwards. Okay, so that 2 kg, it has an acceleration in the upward direction. Weight 2g in the downward direction. Pseudo force, mass into acceleration. What is acceleration? G by 4 in the downward direction, and then there is tension T1 in the upward direction. So mass into acceleration is given by, okay, T1 minus 2g minus g by 2. So 2a is T1 minus 5g by 2. Right, correct. Okay, let's add people all the equations. So what do we have again? 4a plus 2a plus 2a, which is 8a. Again, all the tensions should get cancelled. Minus t1 is cancelling plus t1, plus t2 is cancelling minus t2. What are we left with? 5g plus 5g by 2 minus 5g by 2. So 5g by 2 minus 5g by 2 is also cancelling each other. We are just left with 5g. So acceleration is 5g by 8 people. This is acceleration. And now we already know we don't need to calculate t1. So we don't have to calculate t2. We can directly calculate t1. So let's just calculate t1 because that's what we require. So 2 into what is acceleration? 5g by 8. This is t1 minus 5g by 2. So I've got 5g by 4 plus 5g by 2. This is t1. So t1 is 15g by 4 people. Okay, t1 is 15g by 4. And what was our spring balance? 2t1. You know? So final answer. Spring balance was 2t1 people. You know? So 2 into 15g by 4. 2 into 15g by 4, which is 30 by 4, which is 7.5 g. So our answer mass reading should be 7.5 kg, which is not there in the option. Have I done any calculation?
Yes, sir. मैं भी वही सोच रहा, मुझे भी same ही answer आ रहा है.
Same आया ना? So okay, then our answer is correct. Don't worry, it has to be correct. I must have done something, or I may have added things from my end too. It's okay.
Excuse me, sir.
हाँ हाँ
सर
बोलो.
इसमें हमारी जो स्प्रिंग की इक्वेशन है वो 2t1 minus kx is equal to mg by 4 होनी चाहिए थी ना?
No. The thing is, again, when they will give you spring balance or whatever, so
स्प्रिंग की वजह से रिस्टोरिंग फोर्स लगेगा.
the system, I mean, this pulley will be in equilibrium already. If the pulley is already in equilibrium, so whatever is the tension felt, that will be same as kx. That's what now. Tension and kx will be equal, and that will be the reading that will be mentioned here. What happens is when the string will be pulled in the downward direction, whatever is the spring, that will stretch accordingly, and whatever is the pointer that is attached to that, to that spring, because it will be stretched, that pointer will also read accordingly. Okay, so tension itself, the 2t1 itself is going to give you the reading, because the spring will be in equilibrium. It is not going to accelerate up and down. So kx1 will be equal to 2t1 actually itself, and system will be adjusted such that your answer, as they have mentioned, it will be in terms of mass. So no, don't worry about that thing. Okay, but okay, our answer is 7.5. Should I just confirm this then? Just give me a minute.
Yes, sir. Please confirm it.
Okay, no, it's not from HCV. It's from some probably random problem that I took from internet. I also searched for problems on Newton's law, and I think I took screenshot and typed it probably. But okay, we'll confirm it eventually. I mean, related to the answer, our this concept is not wrong. Concept is absolutely correct. Answer is going to be 2t1, and whatever is the answer, that should be the answer. But why the answer is not matching? Maybe it has to be some typo error or whatever. But okay, interesting. Okay, so I'll just check this out later and maybe tell you guys tomorrow about it. But our answer 7.5 kg as of now. Keep that in the box. Figure shows a wedge of mass 2 kg resting on a frictionless floor. A block of mass 1 kg is kept on the wedge, and the wedge is given an acceleration of 5 meters per second square towards the right. Then it's an MSQ, by the way. Okay, so one or more options could be correct. However, I have taken this question purposely because to also tell you one thing related to MSQ. But first, let's solve this. So they have given us a figure, a wedge, a mass, and it's on a frictionless floor right now. I don't think we'll be having time to cover friction today. I've taken too many problems, but okay, it's good only. A block of mass 1 kg is kept on the wedge, and the wedge is given an acceleration of 5 meters per second square towards the right. Because we have thrown this on the right with an acceleration of 5 meters per second square. The question is, the block will remain. Okay, so what will happen to the block? Whether first of all it will remain stationary or not? That's the question. Whether it will remain stationary or whether it will have an acceleration. Okay. So again, what is the concept that I should apply here in order to solve this question?
Pseudo force.
pseudo force. So let's immediately throw our friend Sharat Kande people on this. He is going to observe this block, people. Just observe this block. Okay. So immediately, because the system is accelerating in the forward direction, there has to be mass into acceleration, pseudo force in the backward direction. This mass is 1 kg. Yeah? This mass is 1 kg. So 1 into acceleration in the backward direction. Okay. There will be a normal reaction. There will be a normal reaction. There is a weight 1 into gravity. There is a weight 1 into gravity. Okay. And there is a tendency of motion in this direction. This is a tendency of motion. So I'm going to choose this as x-axis and this will be my y-axis. So all my forces must be along x and y. Okay. So 1g is neither along x nor along y. 1a is also neither along x nor along y, but normal reaction is already along y. So we have to resolve 1g and we have to resolve 1a. So why do I feel we have done a very similar problem in the class, but just not with the values?
Yes, sir.
Yes,
So we
sir.
should
We have
have the
done.
result of this also. And we have also calculated normal reaction, net force, everything, just not with the values. Okay, people, let's not do this then right now. That's what I feel. I will just tell you the answer of this. Very ditto problem we have taken in the class. You can tell me, but if you want me to do this in the class right now.
तो
Anybody?
जस्ट एक बार ये जिस
Equations बना दो. हाँ, okay, sure.
हाँ बस.
Okay. So firstly, so we have understood that we have resolved the forces. Important is don't choose this as x-axis. Huh? That's a common mistake that you may do, and that will give you complicated equations, people. We will always choose x-axis as the direction of acceleration, but of what? Acceleration of what, people? Acceleration of the object you are observing. You are observing this now. This has a tendency to go in the downward direction. So this has to be our x-axis, and the perpendicular to that, that should be y. So let's resolve things. So I have got 1g, I have got 1a, and I have got normal reaction. And this is my x-axis and this is my y-axis. Normal reaction, it will go untouched because it is parallel to y already. Let's talk about 1g, people. Let's resolve 1g into components. So this will be y component and this will be x component. Huh? Y and x, correct? This is 1g, people, y component, x component. Now listen, this is 37, okay? So this will also be 37. We know this, like the whole property we have done a number of times. If this is theta, and this is also theta. Okay, so this is also 37. So this is 1g cos 37, and this is 1g sin 37. Okay, normal reaction you are not going to touch, but acceleration can be resolved in two components. Let's resolve acceleration. One component, second component. Okay. Now listen, what about the angles? People, this is 37. Again, this will be 37.
Yes, sir.
Correct? The whole same story. If this is theta, this is 90 minus theta, this is theta, this is 90 minus theta, this is theta. So 37, 90 minus 37, 37, 90 minus 37, 37. You just keep on repeating the chain. Okay. So this is again 37. Okay. So this becomes 1a cos 37 and this becomes 1a sin 37. We have resolved all the forces. Huh? That's it. Now, first of all, is the block oscillating like this? No, it's stable. It means total upward must be total downward along y-axis. So normal reaction will be equal to, just a second, where did I write 1a? So you can always tell if I have written it at wrong place. This is 1a cos 37 and this will be 1a sin 37. Now it's fine. Okay, this is 1a now. So 1a cos and 1a sin. Okay, so normal reaction is balanced by what? It is balanced by these two forces, blue and green. Blue one, I have by mistakenly cut it over that. But these are the two forces that you have. It is balanced by 1a sin 37 plus 1g cos 37. By the way, 37s are very popular value. I've told you that many a times. Sin 37 is 3 by 5. Correct now? No.
Yes, sir.
3 by 5, which is sin 30, it's greater than 0.2. Barabar. Sin 30
Yes,
is
sir.
0.5 and this is greater than.
और cos 37 होता है 4 by 5.
Yes, cos 37 will be 4 by 5. Okay, so we have got 3a plus 4g by 5. Okay. Next, again, we don't know whether the system is accelerating or not. So this is the tendency of acceleration. So we are predicting there will be acceleration, mass into acceleration. 1 into acceleration. It is given by 1g sine 37 minus 1a cos 37. 1g sine 37 minus 1a cos 37. Okay. So we have got acceleration, which is g sine 37 minus a cos 37. Or I can say acceleration is Acha, by the way, there will be a small problem. This acceleration, you have to write something else. Let's write a dash. This is a different acceleration, no? A dash. This acceleration is a different acceleration. It is not this acceleration, no? It's not 5 people. So write it a dash, please. Here also in the diagram, if I'm not wrong. Okay. So a dash is this. So this will be g sine 37, that is 3 by 5 minus a cos 37, which is 4 by 5. So a dash is 3g minus 4a by 5. We need another equation actually, because we have got 3 unknowns right now. We have got normal reaction is an unknown. We have got acceleration is an unknown. We have got a dash is an unknown. We need another equation. So whom we can look at? Let's look at the wedge people now. Let's look at the wedge. First, if you want, you can copy this.
Sir,
हाँ बोलो.
sir, I got answer of previous question. It's
Uh,
15.
हाँ.
It's
Okay, is it
15.
15? So did we do some error in calculation?
No, sir. The last one, kx is equal to mg by 4. Then no, sorry, 2t1 is equal to mg by 4. Then we get to 15. Mass
But
is equal to 15.
2t1 is mg by 4. That's fine, but that's what we did now. But I'm not sure. So maybe we could have done. I'm not sure. We probably would have done some calculation error also at some place. So okay, do check this, people. I mean, if the answer is if see somebody has got 15 here, so others also you can see if you're getting 15. Maybe we could have done some calculation error here and there. Okay, it's highly likely because we did it in very rush. So okay. So where were we? A dash is 3g minus 4a by 5. Now let's talk about another equation. Let's talk about wedge p. So wedge is moved in the forward direction like this. It has mass m. It has got mg in the downward direction. What is mass of wedge? It's 2 kg, no? Okay. So mass is 2. So this is 2g. Wedge will have its own normal reaction n2 people. Okay. What else is missing on this?
The other mass. It will also feel its weight now.
Yes, so there will be a normal reaction exerted by the other mass people in this direction. Normal reaction is perpendicular to the surface. So there will be N1 also. Okay. So here we have got N1. Okay. Now we will choose this as x-axis because this is acceleration direction and this is y-axis people this time. Okay. So you don't have to resolve N2. You don't have to resolve mg. But yes, we have to resolve N1 people. We have to resolve N1 in 2 components. So let's do that. Okay. I've got N2. I have got mg. And now let's resolve N1. So N1 is here. I have to resolve it in 2 components. Wait. N1 is here. Let's resolve N1 in 2 components. So this is N1 and okay, this is vertical component, this is horizontal component, this is vertical. What about theta people?
37.
Hi, it's 37, but which one is 37? Okay, so this is 37. So this is 37, right? Okay. So this one is 37. Okay. Hannah? See, this was 37 people. So this one will be 37. 37, 90 minus 37, 37. You just keep on creating the chain, okay? So this is 37. So this one will be N1 cos 37. And this one will be N1 sine 37. Okay, good. So, and where is acceleration? Wait. Also, the thing is,
Don't we have to include pseudo force?
no. The point is because the guy is observing this, so we are not considering acceleration. We will be applying only pseudo force in the backward direction. Nothing else. Okay, so here we have to write m. No acceleration. We'll just write m like this. Instead of acceleration, who is our observer? Observer is sitting here. No? Observer is sitting here, people. So when you are on the platform, you don't know whether the platform is moving or not. Okay. So all that you can apply is pseudo force in the backward direction. That's it. You don't know the acceleration of your train. Okay. So hang on. Because the where is this guy? Because the wedge is going in the forward direction, there will be a pseudo force on the wedge in the backward direction, which is MA. So what do we have? Just a second.
Net left hand force. It seems like that.
No, something is still missing out. There has to be a force given to us now. Block of mass m is given an acceleration. Achha, they have given us acceleration. It's moving in the forward direction. That's fine. We have got mg, we have got n, we have got a. What now? Until here, things are fine. This is n1 sine 37. And they have given us acceleration. Why should we include pseudo? But then if we don't include pseudo, this doesn't make sense. Because there is no force on the right side. There should be a force on the right side. Acha, but okay, wait. Figure shows a wedge resting on frictionless floor. A block of mass m is kept on the wedge, and the wedge is given an acceleration of 5 towards right. When you say it's given an acceleration of towards right, what is the meaning of that? That there should be some tension. Like, I think we had taken this kind of a question. I remember now. There was a string, it was connected to a pulley, and there was a tension T. And that tension T was pulling the wedge right now. Somebody should pull the wedge right. Only then it can move on the right side. Otherwise, how can it move on the right side? There has to be a force on the right side. Don't you think? How can it move on the right side? We have taken this problem in the class. Do you remember?
Yes, sir. हाँ, पर एक पुली था. Observer pull कर रहा था उसे.
हाँ, मतलब basically there was, I think, so a wedge here, a mass, and the mass was pulling it. Something like
yes,
that was the
उसके
problem.
weight के हिसाब से.
Right. But the thing is, if they have mentioned that the block is given an acceleration of 5 towards the right, so somebody has to apply that. Okay, so maybe I can change x and y axis in this if I want to apply pseudo, but then I cannot consider mass. Forces, so we have include, there is acceleration. If I don't want to include acceleration, then I have to apply MA here. And if I apply MA here, then somebody must balance it. And if I want somebody to balance this MA, I don't know why should somebody balance it, but something should be there now. In that case, we'll have to let us try some another approach on this. Just thinking. Okay, this is M, this is 2. We have got 2g in the downward direction. We have got normal N2. Okay, and we have got normal reaction N1. These are so definite. I mean, nothing is changing here. And there is an acceleration. If I want to apply, okay, wait, hang on. So there is normal like this. So normal will be up this direction. Don't we have any other force? Okay, I think if you are applying a force, I mean, since there is a pseudo force of 1A on left side on the block, should there be 1A on the right side too? No. Acceleration is in the forward direction. That's fine. 5 meters per second square that they have given us now. 5. Okay, and we have resolved everything mostly here only. I just want to add one thing in this. I'm trying now. I'm thinking we might need to add 1A in the forward direction. But will that help? 2A would be 1A plus N1 sine 37 in that case. Sorry, 1A minus. No, I'm getting negative. 2a is 1a minus. Doesn't work. Try in your books, 2 people. Let's get this done. 2a. We have Acha, okay, what if I don't change the axis of symmetry that we already had? This was x and this was y. What if we keep this as it is? The initial chosen x and y. Okay. In that case, suppose if I apply pseudo force like 2a, let's try that idea. So in that case, I don't know acceleration. Acceleration, I'm just going to keep it a. Okay. So what now? Let's try this last method. If this works, then it's good. Otherwise, we'll just take it later. I hope you understood what is the last attempt that I'm trying here. So the last thing I'm going to try for now is I'm shifting the coordinates, people. I'm using the original xy axis that we had chosen for the first block. Let's try to keep that xy and resolve forces along that and see if we are getting something. And if we are doing that, in that case, you will apply pseudo force because this was the coordinate system chosen as per the observer. Okay. So because you applied a pseudo force on the block, there has to be a pseudo force on the wedge too at the same time. The whole system is moving in the forward direction now. So there will be a pseudo force on the backward direction too now. Let's try this. Last time, okay? Okay. So now I want forces along. We have got how many forces? 1, 2, 3, 4. 4 forces, and I want all the forces along y and x. Okay. So y is here, okay, and x is here. So n1 is not supposed to be resolved. We don't have to resolve n1. N1 we will keep as it is, but we have to resolve all the other factors. So let's start with n2. N2 is here, n2 is here. What about the angles? Here I had 37, if you remember. So this becomes 90 minus 37, and this becomes 37 once again. Wait, 37, 90 minus 37, 37, 90 minus 37, and 37. Okay, so this is n2 cos 37. This is n1 sin 37. Last attempt, people. Okay, let's try this. And tell me if you have any questions in this idea right now. Otherwise, later it will get confusing. Should I re-explain what I'm trying here?
No, sir.
All good?
No, sir.
All good, you said, no? I did not understood. Okay. If somebody needs a re-explanation, let me know. So n2 cos 37, n1 sin 37. And then let's resolve this 2a2. So we have got 2a cos 37 and 2a sin 37. N1 is not supposed to be touched, and 2g we have to resolve. We have got 2g just a minute. 1, 2, 3. Okay, MA. 2g cos 37, and this is going to be 2g sin 37. Okay. Now let's talk about x-axis and y-axis. Since you have applied pseudo force, total up should be total down and total right should be total left. There is no acceleration right now. You don't know because you are inside the train. Okay. So total up n2 cos 37 is total down. 2a sin 37, 2g cos 37. 2a sin 37, 2g cos 37. Okay. And total left is total right. Okay, now we are getting something. And okay, good. Phew. Okay. So n1 sin 37 plus 2a cos 37, we are getting something. I hope this is only logical and we get the result. This is equals to total right, which is 2g sin 37. Okay. What after this? What after this? Now that's the question now. So we have got n2 n1 relationship again. And here also we had what are the relationships that we already have? We have got n this is n1 by the way. The original n is n1. Huh? The original n is n1. So we already have n1 relationship. So I think we can derive another n1 relationship from her. Okay, let's write this neatly. So we have got n2 cos 37, which is 4 by 5. This is equals to 2a sine 37, which is 2a sine 37, which is 3 by 5. Okay. Then 2g cos 37, which is 4 by 5. Good. Next. And what is the other equation? n1 sine 37. So n1 sine 37, that is 3 by 5. Sorry, no, 3 by 5. Then 2a cos 37. So that's 2a 4 by 5. This is 2g sine 37. So 2g into 3 by 5. You can tell me if by any chance I have written anything mathematically wrong. Physically, I think we have done it correctly. And we can substitute the value of n1 from the original equation. What is n1 equal? n1 is 3a plus 4g by 5. We can substitute this. n1 is, and we will get acceleration. 3a plus 4g by 5. Answer is probably just option C. Just option C. It's MSQ, but at the end of that, I want, like I said, I wanted to tell you all that in MSQ also you can have MCQs, people. In fact, because one or more options can be correct. So one can also be correct, but two or more can also be correct. That's the idea. And I think in last year or last year's paper, out of 10 MSQs, 3 were actually kind of MCQs only. Only one was only correct. Okay. But okay. So let's complete this. 3a plus 4g by 5. This is 3 by 5 plus 8a by 5. This is 6g by 5. So multiply all of them by 5 and you get rid of 5. So we have open the brackets. 9a plus 12g. This is plus 8a. This is 6g. So we have got everything is in plus. 9a plus 8a, which is okay. We are getting negative now.
5 is missing, sir.
5 is missing from where?
Sir, 3 plus 4g upon 5.
3 plus 4g. Achha, okay, there is a multiplication here, no? Yes, okay. So there is 5. Okay. So we have got 9a plus 12g plus 5 into 8. That's 40a. This is 6, 5. This is 30g. Are we getting something now? 49a. This is 18g. So a is 18g upon 49 by any chance if the calculation is correct. So anyway, we got an acceleration. We are getting something. Calculation could be hilarious also. Acceleration so far is this. What we can check is this. So anyway, option A and option B, that is not matching. That's good indirectly. Normal reaction, let's find. Normal reaction of the block. Are we getting 11 or not? Let's just see. If not, then we can again just check the calculations later. Normal reaction, just find n1 people. Where can we substitute this? Here. 3a plus 4g by 5. Okay. n1 is 3a plus 4g by 5. 3a plus 4g by 5. By any chance, if we get the result, then it's good. Okay. I will just confirm the calculations here. 3 into 3, that's 9. 4 into 3, that's 12. 8a and 6g. And then 5, 5, 5 got cancelled. And then 5. 8, 5 are 40, 30, which is 18g and 49. Okay. So we have got 3 by 5 acceleration, which is 18g by 49. 49, okay, plus 4g by 5. Nothing get cancelled, no? And we are not even close to 11. Are we close to 11 meter per second square? Check the final answer. Sorry, not meter, 11 Newton basically. So 18 threes are 54 and 49 fives are 245 plus 4g by 5. This will be 0.8 plus, okay, it seems like we are getting a result. Bapre. Okay, 54 divided by 245, that's 0.22 people, plus 0.8, that's 1.02 into g, unless and until calculation has got wrong. So 1.02 into 9.8, maybe it's around 9.996, approximately 10 or whatever. Okay, so we are getting around 10. Maybe some calculations somewhere here and there should be hilariously wrong, but okay, our answer, correct answer is 11 Newton actually.
Sir, 12.11.
You got 12.11.
Yes, sir.
I'm getting something else on the other end, but okay, just check. The process is same. I will also maybe try this once more and get a ready-made solution and just will show you it tomorrow. Okay. Chalo, we'll stop here, people.